So we're going to look at properties of logarithms part 2 today. And what we see first on our notes is, or are, the same properties that we saw yesterday. And the difference from part 1 to part 2 is we're going to go the other direction. Yesterday we condensed, today we're going to expand. Same properties, referring back to the same properties. As we look at our first one, we're going to write each expression as a sum and or difference of logarithms, and we still need to express all our powers as factors. What I look at here is, first of all, the fact that we've got division in this problem. And the division goes back to our quotient property, but if you look at the quotient property, it says log base b of m divided by n. When we would expand it, we would write a minus sign, which is where we're going to start when we look at this problem here. This is going to be log of 4x minus log of y. Again, subtracting, because the original problem is division. 4x divided by y. And we oftentimes say 4x over y, but it really is a division. But there is one more part to this that we need to look at. And it says log of 4x. Well, log of 4x means log of 4 times x. There's a multiplication in that problem where we can expand. When we have something multiplied by each other, looking back at the product property, multiplying says that we can expand this by using an addition symbol. So we're going to break down log of 4x into log of 4 plus log of x. I should have written the plus as a red plus there. And then minus log of y. There we've expanded. We wrote that expression as a sum and or difference of logarithms. We had both of them in there. So problem number 2. Similar to what we had in problem number 1, because when we read this, it's log base 9 of x to the 4th divided by 729. Division. Division goes back to the quotient property of logarithms. Nice that you can see that box on your paper, so you can look directly up. When we start this, it's going to become log base 9 of x to the 4th minus log base 9 of 729. But in the first problem, we did the product property and we did the quotient property. This one, we've got an exponent now on that first term. Log base 9 of x to the 4th. So we're going to use the power property. And what the power property says is, if we have an exponent, we can take this value and we can rewrite it as a coefficient. So this is going to become 4 log base 9 of x minus log base 9 of 729. But now, the thing that we need to look at is, we have log base 9 of 729. We know 2 parts of the logarithm. And if we know 2, we oftentimes can simplify, because there's only 3 parts. And what has to happen here on that is we can rewrite this as 9 to what power equals 729. So what that's asking ourselves is 9 times itself, how many times will give us 729? And if you think about your quick recalls from Algebra 2, if you were in Algebra 2 last year, if we break this down, it's 9 times 81 and 9 times 9. So really what 729 says is it's 1, 2, 3 nines. And if you're not sure, then take your calculator and go 9 times 9 times 9. And hopefully it equals 729. And now that we've got that, we can finish with our simplified version here. It's going to be 4 log base 9 of x. Log base 9 of 729 simplifies to be 3. Now, once again, we're applying these properties to rewrite this in the format where we're going to be adding and subtracting. But we want to write powers as factors. So whenever we have the power theorem, we need to make that power a coefficient. But the first part, as we look at problem number 3, that I see is this is log base 3 of 9x to the 5th. So when we rewrite this, it's going to be log base 3, but 9x to the 5th is 9 times x to the 5th. So this is going to be log base 3 of 9 plus log base 3 of x to the 5th. Second step in my head, and it doesn't necessarily have to be the second step here. But the other property that I see in this is that we have an exponent here of 5, and that's where it's express all powers as factors. So we're going to take this value and we're going to make it a coefficient. So this is going to be log base 3 of 9 plus 5 log base 3 of x. But there's one more step on this problem, and that is we can figure out what the log base 3 of 9 equals. Because we know the base, we know the number. We could rewrite this. It's 3 to what power equals 9? Well, most of us know that 3 squared equals 9. So 3 to the p equals 9 is the same thing as 2. And then we've got our plus 5 log base 3 of x. And sometimes what the hardest part is on these types of problems is getting that 2. It's oftentimes not the properties. It's just the simplifying of the log base 9 of 729, the log base 3 of 9. So we have to watch out for it because we can simplify those values. But that kind of gives us the basics here. Let's make it a little bit more complicated now, and I know you can hardly wait to make it more complicated. But here we've got a lot going on in this one. We've got log of 2x squared y divided by 3k cubed. There's a lot going on in this particular problem. By the way, what's the base of a log when there's no base written? It's 10. Let me take a look at this one here. First thing that I notice, hopefully that you notice as well, is there's a division. Just go in parts here. This is going to be log of 2x squared y. Division means that we're going to subtract. And then it's going to be log of 3k cubed. And there, like I said, there's a lot going on here. And that red minus sign we really have to be careful with. But let's deal with the log of 2x squared y first. Because it's 2 times x squared times y. It's all multiplied together. So we can break that apart into this is going to become, just for this left logarithm here, it's going to become log of 2 plus log of x squared plus log of y. It was 2 times x squared times y. So if you keep it in pieces there's one more part here that we need to do to simplify this logarithm on the left here. We're almost done. And that is that we have a power in this problem. And the power property says that we can take the exponent and write it as a coefficient. We take this 2 and we write it over here. This is log of 2 plus 2 log of x plus log of y. But we have more. That's only the left logarithm. And again, the issue here is that there is a minus right there. We need to be really careful with that. What's within the logarithm there is that it's 3 times k cubed. And I'm going to put a parenthesis in here. Because whatever we do to this logarithm, that minus is going to apply to everything. We're subtracting this. And when we expand it, when we rewrite this logarithm that's on the right side of our problem, this is going to become log of 3 plus log of k cubed. It's 3 times k cubed. And we have a power in this part of our logarithm also. And when we have a power in that part, we're going to take that power, we're going to apply our power theorem, which is that we can rewrite this as an exponent. So this is going to be log of 3 plus 3 log of k. And now we can get close to finishing this problem. Again, this red minus sign, it applies to everything that's written in black in that parentheses there. We can finish this problem by distributing that minus sign. So everything in green, it's not going to change. Log of 2 plus 2 log of x plus log of y. Again, nothing there changed. We had it all simplified. Over here on this right side, it's going to be minus log of 3. And it's going to be minus, because negative times positive is negative, 3 log k. The difference on this problem, on problem number 5, is it's dealing with the natural log of e divided by x. We've seen many examples so far where we have division within the problem. So we're going to expand this into the natural log of e minus the natural log of x. But once again, on one of these terms here, we can simplify this function a little bit more. And it's actually the first one, is where we can simplify the natural log of e. If you don't know what it is already, just a reminder here that the base on the natural log is an e. So we could figure it out by hand, but I do want to show you on the calculator that we can use our natural log button. And then if we want to know what the natural log of e is, we can go second in the division bar. If you have an inspire, you're using your e to the x button, you have to put a 1 in for your exponent, or else you're going to get an error on the calculator. But the natural log of e gives us 1, and we can simplify. And we end up with 1 minus the natural log of x. So watch out. Make sure that you've simplified everything. Oftentimes we're just left with a lot of terms that are added or subtracted together. But don't overlook the fact that sometimes we can convert them back into a numerical value. And then we get to number 6. And we've got some funny stuff in here. And the first thing that's funny stuff, so to speak, is, what is this? And what that is simply the domain of this logarithm. And remember, when we're dealing with the domain of a logarithm, it's this whole part, I'm going to erase that circle here in a minute, but that whole part has to be greater than 0. And ultimately what it ends up here is that x has to be greater than 0. When we simplify that, but it's not going to impact our problem, except to say that if we actually give a numerical value to x in a problem, then any numerical value that we give has to be bigger than 0. That's the only restriction there. But in terms of simplifying, that's not going to impact your problem at all. In this problem, it's log base a of x times the square root of x plus 1. We have multiplication. So what operation do we have to do when we multiply? Well, hopefully you're thinking we need to add. So when we start this problem, it's going to be the log base a of x plus the log base a of x squared plus 1. The thing about the square root of x squared plus 1 is it can be simplified more. That value, square root of x squared plus 1. And over here, by the way, this isn't going to change. But we can convert the square root of x squared plus 1. Remember that the radicand, the value underneath the radical, is the base. The number in the check mark part, which in this case is a 2. You don't have to write the 2, but the number in the check mark part of the radical is the denominator. And there's no exponent on x squared plus 1. And in general, something to the 1/2 power means the square root. So we need to go back to those rational exponents rules that we did. I can't remember if we did it a week ago or we did it this week, but not too long ago, to be able to do these types of problems. It's been a week ago. Now that we have this written in this format, we can simplify just slightly more, because once again our directions say express all powers, and that 1/2 is a power. Express all powers as factors. So log base a of x isn't going to change, plus we are going to take this value of 1/2 and we're going to rewrite it as a factor. This is going to be plus 1/2 times log base a of x squared plus 1. We cannot break up x squared plus 1. We can't factor it. It's the x squared plus 1 is attached to the logarithm. So unless we get rid of that logarithm, we cannot break that value apart. So don't try to expand it or condense it. We can't do anything else to the x squared plus 1. As we get close to finishing here, number 7. Natural log again. Remember that not only do the properties apply to log logarithms, they also apply to ln logarithms. So if something is added together, then we're multiplying in a natural log. If something's subtracted, then we're dividing in a natural log. And the power theorem still applies as well. Again, what sometimes confuses people, especially if they don't take some time to practice this concept, is that. And all that is the domain of the logarithm. It's not going to impact how we simplify this, but it does say that if we actually give a value to x, it needs to be a number that's greater than 1. And the reason is 1 minus 1 is 0. So we're not allowed to have a 0 in the denominator. We see division again. Seem to be pretty heavy in division, although I only have really 2 choices when we write this. But it's going to be natural log of x squared. Division means subtraction, and it's going to be natural log of x minus 1 cubed. And on both of these, we have an exponent. So that goes back to the power theorem, which says that we can take an exponent on our argument. If you ever read this on the internet, the exponent on the argument becomes the coefficient. So if the 2 is going to become a coefficient, and the 3 is going to become a coefficient, and then we can finish what we were doing here. Because it's 2 natural log of x minus 3 natural log of x minus 1. And 8, a little bit more complicated to finish. But at least we've seen an example where we've have had to deal with a square root. Now we've got square roots in a couple of places here. But I want to remind you that x is greater than 0 is the domain. It doesn't impact how we expand or condense something. It just simply states that if we actually are going to put numbers to x, any number that we pick has to be greater than 0, because the domain of a logarithm, whether it's an log or an ln, is going to have to be greater than 0. It has to be a positive value. And what I did here, and I'm going to erase this, but what I always did is I said, this value must be positive. Well, I don't know that I would write that on your paper here, but I just want to bring out what I'm talking about so that you can hopefully remember. So when we look at this one, we have division again. And take it piece by piece. So this is log base A of x squared plus 1 minus log base A of x cubed times x plus 1 to the 4th. And if I want to get really technical here, I really think that needs parentheses all around it. Because that logarithm applies to that whole function there. And sometimes I get lazy and I don't write it. But at least mentally in your head, make sure you get that. So make sure that you know that whole expression there applies to that log base A. But I'm going to deal with the logarithm to the left. And the logarithm to the left here, we have a square root. We can rewrite that as the square root. We can rewrite this as log base A of x squared plus 1. The radicand becomes a base. The number in that check mark part is a 2. So our denominator there is going to be a 2. And we don't have any exponent on the entire function of x squared plus 1. So there again, we see the square root of x squared plus 1 is going to go to the 1/2. But if we can convert that, and by the way, the square root of anything can be written to the 1/2 power. That's what I'm trying to stress along with the properties. But now what we're going to do is we're going to take that 1/2, I'm going to write it out in front here. It's going to be 1/2. Then it's log base A of x squared plus 1. And just like example number 6, don't break apart that x squared plus 1. We can't. We subtracted on this problem, so let's deal with what's over here in this second function to the right. Well, it's x cubed times x plus 1 to the 4th. So this is going to be I'm going to put it in parentheses there, but when we break it apart, this is going to be log base A of x cubed plus log base A of x plus 1 to the 4th. And we still have some stuff to do here on this problem. Notably, the fact that we've got a cubed on the x cubed and we've got a to the 4th power on the x plus 1. And that's when we do the power property, which says we're going to take that 3 and we're going to put it out front. We're going to take this 4 and we're going to put it out front for our power property. But I still have this in parentheses here, and I want it in the parentheses. So we have 3 log base A of x. Now we wrote the power as a factor, plus 4 log base A of x plus 1. And lastly, we can finish this problem. When we finish it, we're distributing negative here, and we're distributing there, negative there. So it's going to be 1/2 log base A of x squared plus 1 minus 3 log base A of x. And it's negative times a positive, which is negative 4 log base A of x plus 1.